Okay, we're in section 9.6. We're going to first talk about families of right triangles. So there's a few families that you should start to memorize with your right triangles. So the first family would be the 3, 4, 5 family. So 3, 4, 5. And what that means is that the two smaller numbers are the legs and the largest number is the hypotenuse. So if we were to just draw this, put our right angle there. If this was 3, 4, and the hypotenuse was 5, then it would follow the Pythagorean theorem. Let's see if it checks out. So 3 squared plus 4 squared equals 5 squared. 9 plus 16, is that equal to 25? And yep, it checks out. So when we say the 3, 4, 5 family, there are many different triangles that can fall, an infinite number actually, that can fall into the 3, 4, 5 family, such as 6, 8, 10. And all we did there, these would actually be similar triangles because the angles would all be the same, and all we did, the sides would be proportional because all we did was multiply each side by 2. Another example of that family would be the 9, 12, 15 family. Again, all you did was multiply by 3 to get those numbers. Another family that might not be as obvious, but it would still be part of the 3, 4, 5 family would be 3 root 3, 4 root 3, and 5 root 3. So all 3 of these would be part of the 3, 4, 5 family. And like I said, there's an infinite number of possibilities. All right, your next family. So I'm actually going to highlight this one in yellow because that's the main family. All right, the next type of family that we can have would be the 5, 12, 13 family. Again, if we did the Pythagorean theorem, 5 squared plus 12 squared, does that equal 13 squared? So we have 25 plus 144. Does that equal 169? And the answer is yes. When you add these two, you get 169. So that checks out. So different triangles that are part of the 5, 12, 13 family. Another example we can write would be if you multiplied everything by 3, you'd have 15, 36, 39. So that would be part of this family. Next, we have the 7, 24, 25 family. Again, 7 squared plus 24 squared equals 25 squared. So we have 49, 576 equals 625. And when you add these, you get 625 is equal to 625. So your book gives an example of 14, 48, 50 would fall into this family because you just multiplied everything by 2. All right, we're going to talk about 2 more families. I was running out of room, so I'm start on the back side of this page. We have the 8, 15, 17 family. Again, 8 squared plus 15 squared, does that equal 17 squared? So we have 64 plus 225, does that equal 289? And when you add those together, it does. 289 equals 289. A different family, and let's highlight the family name or the main one in yellow. Another family, if we divide by 2, you can have fractions. So if you had a triangle that had sides 4, 7.5, and then 17 divided by 2 would be 8.5. This family would fit under the 8, 15, 17 family because everything was just divided by 2. Okay, so I'm going to list, I said 2 more, but that's 1 more that we're going to do the work on that we did up here. I'm going to list a few more other families, but the most popular ones we've already listed. So 4 more families. We're not going to do the Pythagorean theorem with them, but we have the 9, 40, 41 family. We have 11, 60, 61 family. 20, 21, 29 family. And last we have 12, 35, 37. So there are infinitely many families, but most are not used very often. Okay, so let's go to the next page. Principles of the reduced triangle. Number 1, the first thing you're going to do is you're going to reduce the difficulty of the problem by multiplying or dividing the 3 legs by the same number to obtain a similar but simpler triangle in the same family. Then you're going to solve for the missing side of the easier triangle, and then we must convert back to the original problem. Okay, so it wants us to find the missing length. So what they would like you to do is look at the 2 legs that are provided, 10 and 24. What number can we simplify both of these by? And the answer is 2. So if I divide 10 by 2, I get 5. 24 divided by 2, I get 12. So now if I had this triangle and I saw a right triangle and it had 5, 12, look at the page with your families. If you need to rip that off while we're doing these notes, go for it. That would fall into the 5, 12, 13 family. All right, but here's the deal. This side is not 13. We divided by 2 on each side. Now we have to convert it back. So if I divided by 2, in order to get the final answer, I need to multiply by 2 to give you your final answer of 26. So that made this triangle simple to find the sides. And pretty soon you'll memorize the families and it'll go a little bit faster. All right, to the left, let's make another triangle that's a little bit harder. So let's draw a right triangle. Sometimes you need to be a little creative. We're going to make this 6, 18 root 3, and this side will be the missing side. So the first thing, when you look at 6 and 18, let's simplify them. Both of them are divisible. We can divide them both by 6. So if I do that, the new triangle would have the side lengths of 6 divided by 6 is 1 here. 18 root 3 divided by 6 would give you 3 root 3. We must take the last side and divide that by 6 as well. All right, this does not fall into a special family. However, we can take these numbers and use them to solve for the missing side, and they're a little bit smaller numbers, so simpler calculations. So we'd have 1 squared plus 3 root 3 squared equals x over 6 squared. And this might look a little scary, but we actually don't ever square this. I'll show you what happens. So 1 squared is just going to be 1. 3 root 3 squared, well, 3 squared is 9, and then the square root of 3 squared would be 3, so we get 27. That equals x over 6 squared, and we're not going to square that. What we're going to do is we're going to add 1 and 27 to get 28. Oops. That's equal to x over 6 squared. Now, I don't want that squared anymore, so I'm going to take the square root of both. So square root of 28, we can take out, you got the square root of 4 times the square root of 7. So that simplifies into 2 root 7, and that is equal to x over 6. Now to get your final answer, multiply both sides by 6, and your final answer for this problem would be 12 root 7 is equal to x. So that's just another way to simplify your problems and get your answers. So we got 12 root 7. Okay, next page. When you look at this triangle, it says find the missing side. So to make it simpler, because there's a 3.5, I hope you would think, hey, let's multiply everything by 2, because that makes this side 7. If I multiply 12 by 2, I get 24. So the special triangles, there is one that has legs with 7, 24, and the hypotenuse would be 25. Okay, so another way you can think of this is that's great. We multiplied everything by 2, so this is the hypotenuse. If I multiply this by 2, I have 2c. Well, 2c is equal to 25. When we divide by 2, our c is equal to 12.5. So this missing side would be 12.5. All right, next one. So there's going to be some figures that are combined together. If you look, you do have 3 right triangles within this figure. So let's start to figure out which triangle we can solve for. So when I look at this, my eyes, like I look at them all and I say, you know what? This one, I have 2 sides with numbers. I have 12 and I have 13. And because this one is across from the right angle, this one is our hypotenuse. So do I have a right triangle that has a hypotenuse of 13 and a leg of 12? And the answer is yes, it is a 5, 12, 13 triangle. Falls into that family. So this side is 5. Now let's look at the middle triangle. Is there a family that has 3 as a leg, 5 as the hypotenuse, since that's across from the right angle? And the answer is yes, it is a 3, 4, 5 triangle. And now for the last one, it's not as obvious because we have this 8.5 as a hypotenuse, but since it has the half, let's multiply that by 2. And we'll multiply 4 by 2. So we end up having 17, 8, and is there a triangle that has 8, another leg, and 17 as the hypotenuse? And yes, it would be an 8, 15, 17 triangle. So that means this side would be 15 when we use the simpler triangle, but since I multiplied everything by 2 to get x, I need to convert it back and divide by 2. So when I divide by 2, I end up getting x is equal to 7.5. They may ask you to specify the triangles, 5, 12, 13 triangle family, and this would be a 3, 4, 5. That concludes your notes for section 9.6.